Hello, and thanks for joining us. I'm Rhonda Schaffler, and today we are going to talk about electric vehicles, but not just as a shift in the transportation sector, but rather as a revolution in the electronics manufacturing business here in the United States. Joining me for the conversation is David Moore, Senior Vice President and Chief Strategy Officer at Micron Technology. Now, before we get started, I want to remind you of a few things. First of all, if you have a question, feel free to enter that in the text chat to the right of the screen. We're going to try to incorporate those questions in our session. And of course, take the poll. We're going to share those results as well if you have not already. So we're going to get into it. Thanks for joining us. And Dave, it's great to have you here.
Thanks, Rhonda. Great to be here too.
Of course, lots of news in the automotive sector around EVs and chips over the past year. EVs, we know, are tech-heavy platforms. Dave, what is driving this trend in the greater demand for auto electronics? And is it a trend that is sustainable?
Certainly, I think recent supply chain challenges have really shown, Rhonda, just how critical semiconductors are to the automotive industry, but I think to a wide range of industries. And certainly in recent years, the semiconductor content, chip content in cars has been steadily increasing and will continue to do so. And I think EVs are definitely accelerating that trend. I think automakers, as they look at electrification, have looked at re-architecting the entire car, right? So certainly on the powertrain and the battery management that you'd expect to see in e-vehicles, but also beyond that into the in-cabin experience, infotainment systems, certainly a growing demand for driver assistance and advanced safety. And so all of these are really driving a significant increase in the demand for semiconductors. And also, Micron as a global leader in memory and storage solutions sees that opportunity, as committed to supporting it. In fact, we see, Rhonda, over the next few years, a tripling in the demand for memory and storage. And that's really just on an average basis. Obviously, as we get into more electrification and more autonomous capabilities, that demand is only going to increase several-fold.
I actually, Dave, want to get to the poll right away, because when we're talking about demand, I think this says it all. So the question is, which application requires the most lines of software code? And internet-connected cars top the list over F-35 fighter jets, the space shuttle, Android OS. So, I mean, it's really pretty amazing when you look at those numbers. And by the way, 56% of our respondents went with internet cars. So they're following the trends pretty closely there. So you've noticed the demand, you've gotten into the business. How has the company pivoted or expanded to capture a market that is growing and, as you just said, is expected to grow even more rapidly?
Yeah, no, I think, certainly as you'd expect, Rhonda, you don't just wake up one day and decide to enter the automotive segment. Micron's, leadership position in automotive is really on the back of 30 years of relentless focus in investment and tight customer engagement and collaboration with the industry. I think the automotive segment in general does demand certain specific capabilities. As you'd expect, stringent safety requirements imply really high quality requirements. And so, our position there recognized broadly as a leader in that regard. But I think beyond that, you look at specific capabilities. There may be operating conditions such as temperature, low power. There's a big focus on providing functional safety capabilities. And so we're very proud to have our industry first functional safety certified memory products. Beyond that, as you might guess, there's differences between other consumer markets and automotive in terms of the expectations our customers have for long availability of supply to meet their life cycle requirements. And then I think beyond that as well, expertise. We've got a lot of customer engineering labs really located very close to our customers, where we're able to engage our customers on next generation system requirements and really mesh our shared roadmaps for today and the future.
And in terms of just your own expansion, you really have to be focused on all these areas, right? I mean, you can't weigh one over the other.
Absolutely. I think, it's certainly a market where commitment means a lot to our customers. So making sure that we're investing both for the near term and for long term is extremely critical.
So Micron serves a lot of different markets, a lot of different industries. Which specific end markets are fueling growth? We're talking here about EVs, but when you look at big picture, what are you seeing?
Yeah, no, I think the growth in memory and storage really has been unprecedented. Just in the early 2000s, memory and storage were just 10% of the global semiconductor market. Today, they're at almost 30%. So just significant growth over the last 2 decades. And that growth is expected to continue. We expect to see exponential demand, obviously digital transformation, pervasive AI, hyperconnectivity, and 5G. All of these are driving very, very strong long-term secular forces for data. And so we see growth certainly in our data center markets, the cloud in particular, as cloud service providers roll out new services, as AI becomes more pervasive in workloads in the data center. We talked to automotive, clearly a very significant opportunity and fast-growing market for us. But industrial IoT, right? Factory automation, security systems. And then beyond that into our consumer markets where we see content growing in mobile, we see it growing in PC. And there's also exciting opportunities in enabling more immersive virtual experiences. So I'm sure you in the audience have heard plenty of talk about the metaverse. Obviously, there's opportunity there for memory and storage as well. So really broad-based long-term growth drivers that are going to double the size of the memory and storage market from about $160 billion today to about $330 billion by the end of the decade.
These are numbers that I think, decades ago, nobody really would have imagined. We're building this kind of as a manufacturing revolution. So let's dig in the weeds a little bit on that. What are we seeing that's different with the manufacturing process that's more intense? Obviously, you're scaling up.
Absolutely. I mean, I think, there's an investment on making sure that we're at the leading edge of technology, but there's also a significant investment too in ensuring that as we look forward, we have the supply to meet that growing demand. And so we announced late last year a plan to invest $150 billion in R&D and manufacturing globally over the next decade. And that's really going to fuel and leverage our investments towards meeting that demand alongside all of our technology and increasing product development capabilities.
We need more production in the United States, though. So let's talk about that. Why has the U.S. been lagging compared to other countries? Is it primarily cost, or are there other factors that weigh in?
I think it's a great question and an important one. I think at the time we're at right now, certainly there are many factors, but important among them really is that other countries have been investing in their semiconductor manufacturing capabilities for multiple decades. Hundreds of billions of dollars have been invested. And we've seen other countries around the world too recently announce their intent to support this industry with incentives. And so we've seen what the effect of that has been. In 1990, about 37% of the global semiconductor output was manufactured here in the US. Today, that's down to 12%, Rhonda. In memory, it's even more stark, actually. Only just 2% of the global supply is manufactured here on US shores. And all of that is from Micron. We are the only memory manufacturer in the entire Western Hemisphere. And so clearly, there is a significant opportunity to look at, I think, improving, I would say, the overall balance to that. I think there's certainly a risk that the US is going to fall behind and continue to fall behind in terms of its competitiveness. And so that's why legislation such as the CHIPS Act and funding that, enacting really critical investment tax credits for the industry is really, really critical to really offsetting some of that differential. It can be up to 45%. In terms of cost delta between the US building and operating a large-scale fab here versus other countries where those incentives have been in place for some time.
I mean, certainly this was brought home during the COVID-19 pandemic when we think of the supply chain issues. And there was a lot of discussion about bringing manufacturing back to the US. I think you kind of hit the point here that it sounds like a great idea, but how can you make it affordable?
I think certainly, the economics are very real. When it comes to memory manufacturing at leading edge, it is extremely cost competitive. These are large scale investments too, Rhonda. I mean, it costs tens of billions of dollars to build and operate a leading edge memory fab. And so we've put forward our plans to invest 150 billion over the next decade, but it really is going to require sustained government support. That long-term demand I talked about earlier, that's only going to continue to grow. And so in order to be able to build that capacity and build it here in the US, that sustained government support in the form of incentives to offset that 45% or up to 45% cost delta is going to be really critical. And that's why chips and the investment tax credit in particular are important.
Why do you think it's stalled in Congress?
I think, certainly there has been progress, and certainly commend the leadership across Congress and the administration for all of their efforts to move this forward. I think largely too, there's bipartisan support for these provisions, right? So it's not political, it's really foundational to, our long-term competitiveness. It's foundational to securing our supply chains, in which regard it's important for our economic security in the long term. It's also critical too for our national security. When we think about kind of the fact that memory and storage and semiconductors generally are in every electronic system in the planet, and that includes industrial systems such as factories, the grid, transit systems, advanced defense systems, all of these depend on memory and storage critically. And so where those, devices and chips are designed and manufactured for many of those applications can make a difference. And I think, for those reasons, really, it's critically important that we look at, this historic opportunity to be able to rebuild advanced manufacturing capabilities and overall output from here domestically.
Tell me your thought process in terms of strategy when you came up with the R&D commitment that you've made. I mean, how far out were you looking? What was kind of going through your mind in terms of budgeting that and really trying to position Micron for the future?
Yeah, so the $150 billion that Micron announced was across both R&D and manufacturing over the next 10 years. And that investment was spelled out to be a global investment. But clearly, there is an opportunity, and we are actively assessing potential opportunities for a DRAM megafab site here in the US. Those investments, as I said earlier, they cost tens of billions of dollars. They also have some particular requirements too in terms of the site itself. A DRAM megafab, the scale of it is really eye-popping. It is, millions of square feet. And so as you might expect, we have certain requirements that we need from a site perspective. We have certainly requirements that we need to meet in terms of, the talent and how we, address the talent needs that we have. Beyond that, obviously utilities, water, electricity, and making sure too that we're able to uphold our aggressive sustainability goals and vision as well.
What have you had to do in terms of workforce development to help Micron achieve some of these goals and expand development and manufacturing?
Yeah, so certainly, talent is critical in all of this. So advanced manufacturing is a highly technical endeavor. It requires a highly skilled workforce. And so that's one of the great opportunities here, right, is to be able to, really deliver tens of thousands of, high-paying, highly qualified jobs. But you're right, in order to be able to support that demand for memory and storage, you need to be able to support the demand for talent. And so it's really around, I think, partnering as Micron with the industry and with government on developing STEM pipelines, continuing our partnership. We have a fantastic track record in partnering with universities to make sure that we're promoting STEM from a curriculum standpoint, a lab standpoint. Beyond that, looking at kind of ways where we can, help with reskilling and upskilling our workforce as well. And beyond that, looking at traditional and non-traditional means, really just to widen that pipeline and make it as diverse as we possibly can for the long term.
Let's circle back to electric vehicles for a minute. In terms of the development, how much more memory are these vehicles going to require? I mean, it's hard to imagine that there's more bells and whistles to put into a car, but then you know what? 2 years later, there's a car with more bells and whistles. So do you have any sense of kind of where we are in the development scale?
It's a great question. I think, certainly when you look at, the modern re-architecture I talked about, I still think we're in some of the early innings in some of the driver assist and infotainment demands. I think the big shift is really going to be as we get to more semi-autonomous and autonomous capabilities, where we get to the point where, when you get to all the way to level 5 or fully autonomous self-driving, you just have to imagine the immense wealth of sensors and processing and data that's required. That example earlier in the poll, right, where lines of code for those in the audience who aren't maybe so technical is really just a proxy for the complexity of the system. And so you can see that already we see connected vehicles, demanding a huge amount of complexity, a huge amount of memory and storage, obviously, to store that code and data. But as we move forward in terms of enabling autonomous systems, in full, that's really going to drive the content up. So we could see an order of magnitude increase in memory and storage demands for increasing levels of autonomy in automotive out there today.
And just a question from the chat I want to jump into, and thank you, Yuri, for your question. McKinsey and Company made a lot of progress tightening belts around companies, but also accelerated back office outsourcing, Drucker style. The value of vertically integrated systems becoming increasingly appreciated now. Maybe you could just respond to that, because certainly something I'm sure you're thinking about at Micron.
Certainly, I think when we look at, if I judge it correctly, the question is really around supply chains and vertical integration. I think certainly, as we've looked at the challenges of the recent supply chain, crisis, I think we've certainly seen the opportunity to be more transparent across up and down, upstream and downstream in the supply chain. We also, though, to see that the supply chain is fragile. And, what we need to be able to do is realize that the shocks we had due to COVID and others, we will have more shocks in the future. And so it's really about arming ourselves to be able to withstand those and be more resilient. And I think one of the major risks we do see is geographic concentration of semiconductor manufacturing in other parts of the world, particularly in Asia, is a risk long-term to that, assurance on supply chain. I think that's a very important focus for us, and obviously germane to the conversations we just had around manufacturing and how we, really bring advanced DRAM manufacturing in particular, from Micron's perspective, here to the US.
Right. I think that national security point you raised is an interesting one. And it's certainly something that's been raised before. So you would think that there is a heightened awareness when you have that in mind, plus the pandemic, plus the fact we're still seeing supply chain shocks. You look at the inflation data that came out today, for instance. So it's not like the supply chain issues are behind us.
They're certainly not. And I think they will continue to persist, and new shocks will come, like I say. And so it's really about, learning from the past, obviously, across the industry and with our customers, but also too, in terms of looking forward and making sure that we've really built, the right plans to ensure better resilience in the supply chain, better assurance for some of those, especially those mission critical applications that I mentioned earlier, right? In terms of industrial and defense applications, for example, all of those depend critically on memory, and many increasingly on advanced leading edge memory. And so I think it's really important, for Micron and as an industry, that we really look at this through a national security lens, in addition to obviously the critical importance of creating more, highly skilled jobs and ensuring our economic security as a result as well.
You were mentioning that we're in the early innings in terms of EV. I often think about what we're seeing on the commercial side in terms of fleets and the opportunity there for companies to massively move to EV. I mean, that's certainly something that hasn't been fully factored in just yet.
I think it is really interesting. I know that I think I read some articles earlier last week talking about these kind of inflection points where certain countries, as they get to 5% e-vehicle adoption, it's really an inflection point or a tipping point, and it really accelerates from there. And I think the examples you're highlighting in terms of, fleets, increasing levels of electrification and autonomous kind of, capabilities are really going to accelerate this. And so I think, both in terms of the automakers themselves and the countries, we're seeing these tipping points in adoption that are only going to increase. Obviously, environmental and sustainable demands are a big influence there too.
So just as a strategy guy, I mean, how excited do you get about that we're really on the verge of something much bigger than what we're seeing now?
It's a great question, because as somebody who's been in the semiconductor industry, I usually say 2 decades, but let's say 2 decades plus, this really is an exciting time, but it's a really important time as well, right? I think we've never seen technology and the semiconductors that underpin it have such an impact on how we, work and how we play and how we live and how we learn. And so it really is an exciting time, but it's an important time for the semiconductor industry too. And I fully realize that as well. And so from a strategic standpoint, we really want to make sure that we are looking forward. Many of these investments have a long-term implication for them, not just for Micron and the industry, but for that economic and national security that I talked about earlier.
Well, David, it's been great talking to you. That is all the time we have for today. But I want to thank David for joining me, and thanks Micron Technology as well.